from previous episodes, we know that covalent bonding has two types, nonpolar and polar. And to show the differences between the two, we're going to use some examples. So for nonpolar, we're going to use the example that we used in the last episode of H2, which is usually hydrogen gas. We're going to draw it like that. And for the polar example, we're going to use an example that you're probably familiar with of H2O. Now, return to the nonpolar side. We know from other episodes that each atom wants to satisfy its octet rule. And because these are two of the same atoms, two hydrogens, they both want one extra electron. So as a result, they both pull on them. This atom wants some, and this atom wants some. As a result, when we draw the electron cloud, which is where we can find the electrons in this molecule, they're shared equally between the two. There's an equal chance that they're on this atom, and there's an equal chance that they're on this atom. Now, in comparison, we can look at H2O. So we know from our episode on ionic bonding that oxygen is electronegative. This is because it really wants to satisfy its octet rule and pull in two electrons. So now when we draw the electron cloud, which is once again where we can find the electrons, I'm going to draw with an arrow. We can see that many of the electrons are drawn towards this oxygen. So as a result, because this oxygen is pulling all of these electrons to it, it has a slightly negative charge. And this S is a symbol used in chemistry to denote electronegativity in a molecule. But I like to think the S stands for slightly, so slightly negative. And on the other hand, because these hydrogens are losing their electrons, they become slightly positive. And as a result, we can see the difference. Nonpolar molecules have an equal distribution of electrons, while polar molecules have an unequal distribution. Because of this unequal distribution, there are many interesting properties of polar molecules that we can get into. But as we can see, first off, there's already a bent shape to the molecule. We can differentiate between nonpolar and polar bonds by doing some calculations. We do this by subtracting the electronegativity of two atoms in a bond and finding their electronegativity difference. So for our nonpolar molecule, let's do H2. So hydrogen has an electronegativity of 2.1. By the way, these values will be given to you in a class, and you don't really need to memorize them, but you'll become more familiar with them as you do more problems. So 2.1, and we're trying to find the difference, so let's subtract it from the electronegativity of this atom, which is also 2.1, because they're both hydrogen. So 2.1 minus 2.1 is 0. Now let's try the same calculation for our polar molecule. Here I have 1/2 of an H2O molecule. This is because you're really finding the polarity of one bond. So I only have the oxygen bonded with one hydrogen. In reality, there's another hydrogen over here, but I'm not showing that just to keep it a little simple. So we know from here that hydrogen has an electronegativity of 2.1. And we can subtract that from the electronegativity of oxygen. Let me check my chart, and that is a value of 3.5. When we subtract these values, we'll get negative 1.4, but we're really looking for absolute values. So I'm going to put 1.4. 1.4. So what we see is that nonpolar molecules actually have a lower electronegativity difference between the two atoms, while polar molecules have a relatively higher difference. And we can actually visualize this discrepancy on a number line. So if you have an electronegativity difference between 0 and 0.5, that bond is non-polar. And let me clarify, that means if you subtract the electronegativity difference between two atoms in a bond and it comes out to less than 0.5, the electrons are shared equally and is a nonpolar bond. Let's say you do that same calculation and it comes between 0.5 and 1.7. That bond is polar. And as we see in our example of H2O, we get a value of 1.4, which would be somewhere around here, meaning that the bond is polar. Now you might be asking, well, what happens after 1.7? Well, that's where things get interesting. Let's say, for example, you have sodium chloride, and you want to calculate the electronegativity difference. So let me check my chart, and use my calculator. Let me subtract 0.9 minus 3.0, and that gives us an absolute electronegativity difference of 2.1. This means it would come around somewhere around here in the number line. But this isn't nonpolar or polar. But actually, electronegativity differences above 1.7 indicate that the bond is actually ionic. This means as electronegativity differences increases, bonds go from nonpolar to polar to ionic.